Today's lesson, guys, is going to focus in on equivalent ratios. Equivalent ratios we kind of hit on yesterday. When we were talking about them, we just didn't tell you the name. But equivalent ratios are just ratios that simplify to the same value. One of the things we're going to do today is actually really important for our visual learners. We're going to do a process called tape diagram. So we go to that part next. In a tape diagram, it's just a visual model of a ratio in simplest form. Within that tape diagram, you're actually going to see that the boxes for the first number go on top, the second number go on bottom. Your ratio constant, we'll talk about that in a second, go inside of each box. So what am I saying? If I give you a ratio like 3 boys to 2 girls, to draw your tape diagram on that, you're going to draw 3 boxes on the top. Why? Because the first number is 3. You're going to draw 2 boxes on the bottom. Why? Because my second number is a 2. Does that make sense? We also need to label our tape diagram. So look at what it is you're representing for each of the boxes and put I like to just use a letter. You can write out the whole thing, but I'd like you guys to get used to identifying your variables. So in that case, what I'm going to do is somewhere on my page, I just say that B is boys and G is girls. That is called identifying our variable. So now the rest of the time on this page that I use those 2 variables, I know what they are. So does this make sense so far? Yes. Okay. Now within a tape diagram, we also have what's called a ratio constant. The ratio constant is a number used inside of a tape diagram to show how much each box equals for an expanded ratio or an equivalent ratio. So for example, if I had a ratio constant of 5, whatever ratio constant I go in, guys, every box gets. It never changes inside. That's why it's called a constant. Okay? So this means this would actually represent how many boys? 15. And how many girls? So what we're saying is 15 boys to 10 girls is an equivalent ratio to 3 boys to 2 girls. Make sense? Okay? And literally, I can put whatever number I want to in there, and as long as it's the same number for every box, it will form an equivalent ratio to 3 to 2. Pretty cool, right? Now, another way that we can determine equivalent ratios is what we call cross-multiplying. So if I give you 2 fractions, and I multiply the denominator by the numerator on the opposing side, and I get the same number, then I know that those are equivalent. Now, one reason I prefer to go bottom to top is if I write that number on each side, if they are not equivalent, it will also tell me which fraction is larger, because the side with the larger number is the larger fraction. Okay? Any questions on the first part on the vocabulary side? Okay, so let's go down to the second part. The second part of today's lesson is really designed to try to help you guys and make your life better, especially when it comes to simplifying. When we simplify, there are 4 key numbers that you always need to check. Those 4 key numbers are 2, 3, 5, and 7. Why those 4? Because that is your first 4 prime numbers. Every other number up to 121 that is not a prime number can be divided by one of those 4 numbers. Okay? So if you look at a number and you try to divide it by all 4 of those and you can't, that means it's a prime number. We'll get into prime and composite later. But just understand that those 4 are going to tell you whether or not you can simplify. To help you understand really quickly and make this a quick check for you, we're going to give you divisibility rules. Okay? I know a number is divisible by 2 if it's an even number. In other words, it ends in a 0, 2, 4, 6, or 8. So I don't even have to look at the first number or multiple numbers if it's a longer number. All I have to do is focus on that last number. If it's any of those 5, I know I can divide it by 2. The rule for 3 is actually kind of cool. To determine if a number is divisible by 3, all I do is I add up the individual digits. If that number can be divided evenly by 3, then the whole number can be divided by 3. So what do I mean by that? So let's take a number like 1,278. Let's add up the digits. What's 1 plus 2? 3 plus 7. 10 plus 8. Can I divide 18 evenly by 3? Yes. Yes, 3 times 6. Many of you got out in BizBuzz on that one, but 3 times 6 is 18. So 18 would be a biz. That means this whole number is divisible evenly by 3. Doesn't tell me what the other one is, but it tells me that I can. So why is that important? Because if I had a fraction like 1,278 over 2,467, to see if they can both be divided by 3, now I do go through that same process. What's 2 plus 4? 6. 6 plus 6? 12 plus 7? 19. Can I divide 19 evenly by 3? No, so I cannot divide 2,467 by 3. So I don't have to actually do the math. I can actually just quickly add it up to determine should I or should I even not bother. Make sense? Okay. The rule for 5, really simple. If the number ends in a 0 or 5, I can divide it by 5. You guys should know that one. Literally, that comes from like 2nd grade. And then last one, the 7s. 7, there is actually a trick, but I'll be quite honest with you. The trick is so complex. For me, it's actually easier just to do the quick single-digit division. You do have to know your 7 math facts down cold, guys. So if you're still struggling with multiplying 7s, work on it. You've got to be able to know if a number is divisible by 7. Okay? Now, to simplify, all you're going to do is you're going to check both the numerator and the denominator for all 4 of your key numbers. If I check them both and I say, can I divide the top by 2 and the bottom by 2? If I say yes, then I do it. Then I check the 3s, then I check the 5s, then I check the 7s. If you go 4 times, if you check them both and say, nope, can't divide them both by 2, can't divide them both by 3, can't divide them both by 5, can't divide them both by 7, that means it is in simplest form. So it actually gets to be a really easy check if you focus in on your 4 key numbers. What are my 4 key numbers?
2, 3,
Good. Get used to it. 2, 3, 5, and 7. Now, to find equivalent ratios, we're actually going the opposite. So simplifying reduces it down. Expanding brings it up, makes the numbers larger. And sometimes they'll ask you to expand the ratio. If they do, all you need to do is multiply both the numerator and denominator by the same number. Little Mr. Moore hint, make the math easy. If they don't tell you what to do, pick easy numbers. Mine are 2 and 10. Those are the 2 easiest ones to multiply by. You could do, again, any number you want to, but keep it life easy on yourself. Any questions on any of our notes? Anybody? Okay. Do me a favor then. Go ahead and turn back to page 8 in your modules. Okay, we're not going to do exercise 1, so we're going to start at exercise 2 down at the bottom of the page. Again, starting with marking our text. So we have Shani and Mel. They are using ribbon to decorate a project in their art class. The ratio of the length of Shani's ribbon to the length of Mel's ribbon is 7 to 3. Draw a tape diagram to represent this ratio. So that is our task, or our directions. We need to draw a tape diagram. So going back to our notes, to draw a tape diagram, I'm going to go from the ratio that they gave me, 7 to 3. I'm going to draw 7 boxes on top, because that was my first number. So you can just do a big box, and then do 7. And then the second number is 3. Now to make this easy, put them right on top of each other, and make sure that they match up. So I'm going to draw my second one right underneath. I'm just going to extend those lines down so that they are all equivalent.
Guys, when he marks his text, he should be marking yours as well.
Yes, please mark your text, guys. We also need to label our tape diagram. So this one's pretty simple. I have Shani on top. She's got 7. I have Mel on bottom. And I identify my variables. So S is Shani, and M is Mel. Now, if our ratio constant is 1, we don't have to put it in the box. Just the box itself represents that number 1. We only put the ratio constant in if it's larger than 1. Everybody have your tape diagram drawn? Any questions on drawing the tape diagram? We're going to get a lot more practice on this throughout the lesson today. Okay, I think we have time to start. So go ahead and turn your page. We'll start number 2 before lunch starts here. Okay, on this one, Mason and Laney ran laps to train for the long-distance running team. The ratio of the number of laps Mason ran to the number of laps that Laney ran was 2 to 3. Do we have any directions or questions on this? Anything to box, Maddie? Supposed to be marking your text, right? I've got it up here for you. All you got to do is copy it into your modules, guys. So there are no tests, and this is, guys, I'll be straight up with you. This is a lot of how Engaged New York works. They're going to give you a situation and data, and then they're going to ask you a series of questions that are all based on that initial data. Okay? So if Mason ran 4 miles, how far did Laney run? So there's a question. So I'll box that. Draw a tape diagram. That's a direction. So I'll box that to demonstrate how you found the answer. So if they didn't have those specific directions, there's multiple ways you could have answered this question. But because it specifically says to draw a tape diagram, we must. So our tape diagram is going to be based on our initial ratio of 2 to 3. So I'm going to draw 2 boxes on top, 3 boxes on the bottom. Again, make sure that they line up. My top one, the first person listed was Mason. So M is Mason. My second person listed was Laney. L is Laney. Now, to solve these problems, they must give you an additional piece of information. If all they gave me is a simplified ratio, there's nothing else I can do with it. But the key for today is in these equivalent ratios is using that third piece of information in order to find out my ratio constant so we can fill in the rest of our tape diagram. So in this case, what was that additional information they gave us? Emma? 4 miles for who? And this is really important. Mason. So you have to put the additional information with the correct boxes. So in this case, we know that Mason ran 4. So if it helps you, you can put it in there because that's going to help me now understand what my ratio constant is. So JJ, can you figure out what number goes in each box? 2. Does everybody see where JJ got that was a 2? Oh, there's lunch. So we'll break for lunch. We'll finish up when we come back, guys. Okay, so right before we left, we had discovered because Mason ran 4 miles, he had 2 boxes. That meant there were 2 in each box. So we have now found our ratio constant. The good thing about the ratio constant is once we find it, every box gets that number. So now for Laney, we can also put in 2's for his ratio constant. Because the idea of equivalent ratios and tape diagrams is they must equal the same thing if you simplified them. So now that we have 2's in all of Laney's boxes, how many miles did Laney run? So if we've done everything that we needed to, remember back to our second day together or third day together when we had you guys do the directions test? Obviously Aaron failed.
I don't remember it.
Okay, this is why we did that. Have we done everything that we were supposed to, guys? No. What didn't we do? Hold on, Madison.
You lost all your trust in all trust that you had.
Technically, guys, listen up. One person at a time. Please raise your hand to answer. So technically, we already did divide by 2 because we started with our simplified ratio of 2 to 3. JJ? Do we need a final ratio? Is that what we were asked in this question? Maddie? Oh, thank you for letting me know. Guys, did we answer the question that was asked? No. Because we are working in word problems. Word problems require a full sentence response. So get used to that. Our question was, how far did Laney run? We haven't answered that yet, so we will answer it. Laney ran 6 miles. Now have we done everything we were supposed to? Again, guys, if you mark your text, it makes it easy because I have 2 boxes. How far did Lainey run? Have we answered that? Draw a tape diagram. Did we do that? So have we done everything we needed to? Do you see the importance of marking your text? Please do it. Get used to it. You're good, Sadie. You're good. Okay, now that we've done the example, again, normally what Engage New York will do, they give you the information up top. All the following questions are based on that. So using this information of a 2 to 3 ratio for Mason Delaney, we now want you to answer parts B and C. Okay? We'll give you 5 minutes. I said the only one who's talking right now is Mr. Chan. Okay, if Lainey ran 930 meters, how far did Mason run? Here's my question. Draw a tape diagram. That's directions. We box it to determine how you found the answer. So we're specifically telling you how to find it. This again comes off of our base ratio. So my tape diagram is actually going to look exactly like it did before. I have 2 boxes on top, 3 boxes on the bottom. The big difference is, and I don't have to redo my definitions because I did the same ones up top, so they're still carrying on. Here's what changed is my information, right? I now know Lainey ran 930, so I need to now figure out what number goes in each of my 3 boxes. In other words, what's my ratio constant that got Lainey to 930? So JJ, what am I going to do? Divide 930 by, how many boxes does he have? 3. So I take my 930, I divide it by 3, I get 3, 1, 0. So my ratio constant is 310. Once I find my ratio constant, every box gets it. So all of Lainey's and all of Mason's get a 310 for the ratio constant. So how far did Mason go? Okay, am I done? No, what haven't I done yet? Write my sentence, full sentence answer. So, Mason ran 620 meters. Make sure you pay attention to your units as well, guys. They changed it from miles to meters for the second one, so big difference. 930 meters, you didn't even run a whole mile yet, right? Okay. Now, next one, what ratios can we say are equivalent to 2 to 3? So the whole thing is a question. So did they give us any specifics? No? So who remembers from our notes, what 2 numbers did I say to use if I want to find equivalents? Sean? Wesley? 2 and 10. So I multiply them both by 2. 2 times 2 is 4. 3 times 2 is 6. Multiply them both by 10. 2 times 10 is 20. 3 times 10 is 30. There's an easy way to do it. Are there other answers I could have used? Gabe? Yep. I don't know if you guys can hear them all, but he's basically taking all the different numbers and multiplying both. As long as you're multiplying both of them by the same number, you are getting an equivalent ratio. That's the whole idea of equivalent ratios. Is this making sense, guys? Who said no? Please raise your hand and be honest. Don't be afraid to raise your hand. Don't mess around, guys. This is serious. Okay. Just so I know where to focus my efforts on this next part. Okay, good. Thank you for being honest. Okay, our next one. Josie took a multiple choice end of the year vocab test. The ratio of the number of problems she got incorrect to the number of problems she got correct is 2 to 9. If Josie missed 8 questions, how many did she get correct? There's my question. Draw a tape diagram. There's a directions to demonstrate how you found the answer. So what is my tape diagram initially going to look like? What were the 2 things they gave us? Wesley? 2 and 9. So I'm going to have 2 boxes on top. I'm going to have 9 boxes on the bottom. Again, try to make them all equal. It's going to make your tape diagram more significant. What am I going to label it? What did they tell me? They said incorrect, so I to correct. So I is incorrect, and C is correct. So what was the additional piece of information they gave us? Because remember, they always have to give us a third piece, or we cannot find our ratio constant. Emma? 8 questions, what? Okay, so is that incorrect or correct?
If you miss them, did you get them wrong or right? Huh? So is that incorrect or correct?
Incorrect. So the 8 goes with the incorrect. If it helps you guys, put that third piece of information right by the line in your tape diagram, because that's going to help you think through, how do I now find my ratio constant? So how many boxes do I have that I need to equal 8? 2. So what would go into each box? Is everybody okay with that? Is there anyone who doesn't understand how we find our ratio constant? Sylvia, thank you for being honest. So all we did is we said we know it needed to equal 8, right? She had 8 questions wrong. She only has 2 boxes to get to that 8. So really what I'm saying is divide that 8 into 2 boxes to figure out the number I needed to add up to get to 8. So then it ends up as 4 plus 4. Is that 8? Does that work? Okay. Now again, the beauty of the ratio constant is once I find it, every box in my tape diagram gets it. So now even her correct answers also get 4s because we are dealing with equivalent expressions. So I now have 9 boxes of 4. So how many total did she get correct? Wesley? 36. Have we done everything we were supposed to? What didn't we do, Cannon? We did? Madison? We wrote it down. We didn't answer the sentence, though, did we? Because we're still dealing with a word problem. So we need to say Josie got 36 correct. Now we have our full sentence. Now have we done everything? Yes. Everybody are you guys starting to feel okay on this? Okay, I hope so, because I'm going to explain the homework. Then we've got 3 minutes left in class. I'm going to let you try to do part B. But turn to page 12 real quickly, because there's a couple things I need to point out. Okay, most of these directions are relatively easy. Number 1, write 2 ratios equivalent to 1 to 1. You get to choose. There's a lot of right answers. 2 ratios equivalent to 3 to 11. You get to choose. Gives you a lot of right answers. Number 3, the ratio of the width to the height. Guys, which way does width go? Sideways. Which way does height go? Up. Here's the problem. For some reason, students miss that there's a part B to this question. Okay, in part B, they're going to tell you how long each box is. So once I know how wide it is, they've now basically given me my ratio constant to give me my actual measurements. Part 4 is 5 questions. Do not come to class on Wednesday with one of those letters circled and nothing written. That's wrong. You will get a 0 on this assignment. Okay? Let me make that clear. If you come to class on Wednesday with one of those letters circled and nothing written, that is a 0 for your homework. You have to answer all 5 of them. Okay? Any questions on your homework? Okay, relatively straightforward. There's only, 7 problems? So you have 5 days, or you guys have almost a whole week to do it. You should be good. Okay, let's turn back really quickly. I do want you guys to try to do part B. I'm going to give you 2 minutes. Okay, bell's about to ring, so let's just show it to you real quickly. Guys, Josie missed 20. How many did she get correct? Draw a tape diagram. So we're using our same base. We have 2 and 9. Incorrect, correct. Just change to 20, giving me a ratio constant of 10. So we know it was 90 that she got correct. Okay, please put your name tape.